Okay, so recall in class from Friday how we said the importance of doing these problems is keeping in mind that we need to remember what negative exponents do, does its reciprocal, and also how we can use the idea of properties of fractions and how we can add fractions with unlike denominators. So that's what we're going to do here. We saw in number 4 how we see this -1. And this -1 just means that we take this entire thing and find its reciprocal. And then because the bottom now has negative exponents, we now find the reciprocal of those. So x to the -2nd becomes 1 over x squared, and x to the -3rd becomes 1 over x cubed. From here, we need to get common denominators. We see that this fraction, to get common denominators with the second one, would need an additional x on top and bottom. So we end up getting, if we were to simplify this with common denominators, we'd have 1 over x plus 1 over x cubed. And because you're dividing a fraction, that's the same thing as multiplying by its reciprocal. So that would be our end result, x cubed over x plus 1. For number 5, we do the same thing. We look at what has the negative exponents, and we find the reciprocal of just those parts. So we have 8n to the 4th, that stays the same because there's no negative exponents there, minus 4 over n squared, all over 2 over n squared. So we flip that n squared in the denominator. Now we do the same thing we did over here. We just think, well, here we have addition and subtraction of fractions, so we need common denominators. It has a denominator of n squared, so we need to multiply this by n squared on top and on bottom. When we do that, we end up getting 8n to the 6th power minus 4 all over n squared, since they're common denominators, divided by 2 over n squared. Now, dividing by a fraction, as we said over here, what that is the same as is multiplying by its reciprocal, n squared over 2. So I'm just going to erase this. And now we have this statement. N squared is on top, n squared is on bottom. Cancel those out. They all have factors of 2. We can take out a 2. This becomes a 4, and that becomes a 2. So we get 4n to the 6th minus 2. Over here, number 6, we have 4 to the 9th times 8 to the -4th, which is the same thing as 1 over 8 to the 4th, over 16 to the 3rd. And what we see about these is that the bases all have 4, 8, and 16. They all have a common base of 2, actually. The 4 is the same thing as 2 squared, and then that is to the 9th power. 8 to the 4th, that's the same thing as 2 to the 3rd power taken to the 4th power. And then 16 is the same thing as 2 to the 4th, and then that is taken to the 3rd power. So we can simplify this again. This is just multiplying exponents. We now have 2 to the 18th times 1 over 2 to the 12th, and that is divided by 2 to the 12th. Like that. Since this is the same thing as 2 to the -12th, we can actually just say, or just combine these. 18 and 12, we can combine those. That's going to give us 2 to the 6th. And then on the denominator, we have 2 to the 12th. And so 2 to the 6th over 2 to the 12th will just give you 1 over 2 to the 6th. Like that. Okay. All right. Going on to the last set, 7, 8, and 9. Number 7, we see the same rule, actually. This is the same thing as what we saw in number 6. 1, 25, 5, and 25, they all have common bases of 5. So let's change it all. Also, we know that this is just the same thing as an exponential, a fractional exponent. That's the same thing as 1/3. We learned that from Algebra 2. So we can just go ahead and rewrite this. We have 125, that's the same thing as 5 to the third power, but that's taken to the n power, so 3 times n would give us 5 to the 3n power, times 5 to the 4n, over 25 is the same thing as 5 squared, times negative n would give us negative 2n, like that. Okay, and then that's now going to be taken to the 1/3 power. So we can combine everything together. 5 to the 3n times 5 to the 4n is the same thing as 5 to the 7n over 5 to the negative 2n, all to the 1/3 power. When we divide exponents, we're really subtracting those powers, so 7n minus 2n, that's the same thing as 7 plus 2n. So we're going to get 5 to the 9n to the 1/3 power. 9n times 1/3 is going to give you 5 to the 3n power. Keep in mind, since this is a video, and if I am going too fast, you can always pause and rewind and rewatch as many times as you need to really understand what's going on here. I'm not going to be taking it slow because this is a video and you can just rewind it. Okay? Alright, number 8. So notice again we have these negative exponents, so same thing that we did for number 4, 4 and 5, we do the same approach here. That's the same thing as 1 over 3 squared, all over 1 over 3 cubed plus 1 over 3 squared. Just like we said in class, we need common denominators. This has 3 3's, this has 2 3's, so we need another 3 attached to top and bottom. In doing that, let's see what we get. 1 over 3 squared over, now we combine 1 plus 3, that'll give us 4 over the common denominator of 3 cubed. Fraction divided by fraction is the same thing as taking the numerator and multiplying the denominator's reciprocal, 3 cubed over 4. From there we see there's 2 3's here and there's 3 3's there, so we'll be left with 1 3. So our answer is just going to be 3/4. Number 9, same thing. Take your negative exponents, flip it. Y squared minus 1 over x to the 4th over y minus 1 over x squared. And this is just the same thing that we did over here, only with variables. We need common denominators. And over here we need common denominators. So let's see what we end up with. We've got x to the 4th y squared minus 1 over a common denominator of x to the 4th. Divide that by x squared y minus 1 over a common denominator of x squared. So this is fraction divided by fraction. Well, that's just going to be fraction multiplied by its reciprocal. So we see x squareds, there's x squared here, and then there's really x squared squared here. So really we're taking one of those x squareds out and we're going to be left with just x squared. So this will become x squared. So what we see now is, well, this is interesting. We got this part here, x to the 4th y squared minus 1. It looks really close to x squared y minus 1. The difference here is this is really the same thing as x squared y squared. Just kind of taking out that exponent of 2. Notice how that'll be the same thing. So really, this is the same thing as saying a squared minus b squared. X squared y minus 1 squared. So this right here is the same thing as x squared y minus 1 times x squared y plus 1. There's nothing else on this side. This is divided by x squared times x squared y minus 1. And what's great about this is we see common terms cancel out. So what we're left with is x squared y plus 1 all over x squared. Like that. Okay. Let's take a look at the back. It says currently college tuition is about $30,000 a year. That's a lie. If it goes up 5% a year, how much will it cost in 4 years, 10 years, T years? And what we can do is just set up a table. Instead of x, let's call it time. And then, depending on how long we are in college, we'll also have a cost. Well, in the 0th year, we're going to pay that $30,000. That's now, $30,000. What we're going to do is set up a table very similar to what we did in Algebra 2, just seeing as it goes up 5% what it's going to be. So in 1 year, we see we're going to have to pay the $30,000 plus 5% of that $30,000. So 0.05 times 30,000. Well, if we think about our algebra, that's 30,000 times 1 plus 30,000 times 1.05. So if you factor out the 30,000, you're left with 1 plus 0.05, or that's 1.05. Okay? Whatever that amount is, let's call it A. That amount will then go into the 2nd year. So in year 2, what we're going to do is we're going to take that value, A, and we need to do the same thing. We need to add on another 5% of that amount, so 0.05 times A. And what you'll notice is it's always the same pattern. They always have an A in common. We can take out that A, and you're left with 1 plus 0.05 again. And that's basically going to give you your new amount. Let's call it A times 1.05. And since that A actually had, sorry, let's rephrase that. The A actually is made up of 30,000 times 1.05. And then what we're saying here is we're multiplying it by another 1.05. So really what we have is 2 of those 1.05s, or 1.05 squared. So if you repeat that pattern, basically what we can see is in 4 years, you always have that $30,000, and you keep multiplying it by 1.05, 1.05, 1.05, that many number of years. So we have 1.05 to the 4th power. We do the calculation there, and we should come up with $36,465, roughly. Okay, so that's how much we're going to have to pay in year 4. In 10 years, we apply the same procedure, 30,000 times 1.05 to the 10th power, and that gives us $48,867. Okay, so in T years, basically you're just finding the time as the exponent. We multiply 1.05 to the T power. Okay, all right, let's go on. Number 11, a car loses about 10% of its value each year. It costs $15,000 now. How much will it be worth in 5 years, 10 years, T years? So it's doing the same thing, only now it's going in the reverse direction. We're losing 10%.